This is a video walkthrough for filling out the user input variables in PyTracker. I'm opening the application that I've just downloaded off of GitHub in PyCharm and navigating to the main.py file. The user input options are located at the end of the script in a dictionary format. I'm going to leave the output directory path and output folder name options as none. This means that the default values will be used and the output of the program will be stored in a folder called process data within the application directory. To move into the options for the eye tracking files, I need to specify an ASC directory path. So within the PyCharm file tree, I'll find the test data folder, left click on the ASC file folder, and select copy path reference. There are two options displayed, one for absolute path and a relative path. Since I'm using the test data for this example, either option will work. Now that I have my path copied, I'm going to lay down some apostrophes that I will paste the path between because it needs to be in string format. You can also use quotation marks to encapsulate the path as well. I'll quickly show you how to retrieve paths from Finder. You're going to navigate to the file or folder that you want the path of, left click on it, and press the Option key. And finally, select copy as path name. This will copy the absolute path to the clipboard, and we can go ahead and paste this inside of the parentheses for the ASC file directory argument. Moving on to the attach movement column argument, I'll pull up the user guide to show the possible inputs. These options are located under the user input header, and we can find them on page 11 under the eye tracking options subheader. We can list any of these column names, which are from an intermediate file called eyemovements.csv. This file is created from filtering the raw ASC files, so I'll just list a few column names here. In order to determine the ASC metadata keys, we'll go back to the test data and take a look at the ASC file names. It looks like there's a subject number and a block number, so we'll list the ASC metadata keys as subject ID and block ID. The ASC trial set option allows us to generate columns that can be attached to output or used as metadata keys for pairing behavioral data. In this example, I'm going to skip the argument, but a detailed explanation is included in the user guide. Moving on to the ROI template options, I'm going to use the Finder window to locate the test data ROI template. And to retrieve the path, I'll right-click on the file, press Option, and select Copy as path name. Just as I did with the ASC directory path, I'll encapsulate the ROI template path in apostrophes. The calc ROI raster chords option is a boolean which lets the program know if the ROI template coordinates have a raster origin. To calculate this, the aspect ratio of the screen is needed. If the raster coordinates need to be calculated and the aspect ratio isn't provided, then the dimensions of the screen will be pulled from the ASC files. More information on this format can be found in the user guide on page 8. Due to the placement of their origin in the raster format, all coordinate values are positive. Using this trick, we can determine the origin placement by looking at the coordinates listed on the ROI template. So I'll check the ROI template that we'll be using for this configuration in the test data folder. It looks like all the coordinates are positive, So we can leave the calc ROI raster chords argument as false and the aspect ratio as none. Next, I'll fill out the ROI event map options. The ROI event map and behavior test files serve the same purpose in that they work in tandem with the ROI template to tell the program where the dynamic ROI are located on a trial basis for each subject. The behavior test presents this information in an Excel format with all participants in one file, while the ROI event map splits up this information into multiple CSV files. In the future, these two sections will be combined. To retrieve the ROI event map path, I'll use the PyCharm file tree to enter the test data folder, right-click on the ROI event maps folder, and select copy path reference. Then, for a little spice, I'll select path from content root, which is a relative path, and paste this into the argument. In order to identify the proper ROI event map metadata keys, I'll use the file tree on the left to look at the event map file names. And what a surprise, they followed the same naming schema as the ASC files. So I'll list subject ID and block ID for the event map metadata keys. Now I need to specify the ROI event map trial column, which will help the program correctly pair the dynamic ROI events with the auto-generated trial columns made in the eye tracking data. If there wasn't a trial column inside each file, the program will generate one if the add ROI event map trial ID boolean is set to true. In the test data folder, I've provided event maps that contain a trial column, and it looks like the trial column is named trial ID. I'll encapsulate this column name in apostrophes because this value is of type string. The attach event calls option serves a similar purpose as the attach movement column option for the eye tracking data. Each ROI event map file has a column called phase that I'd like to attach to all output, so I'll add this column name here. The ROI event map file name contains input is used to filter event map files, which is helpful if the specified directory contains other CSV files that we'd like to ignore. Since the test data event map directory is clean, we can leave this option alone. The ROI event map import skip rows is used to indicate rows inside event maps that are blank or unstructured. If this option is utilized, then the ROI event map columns needs to be specified, which is a list of column names. Since the event map files used for this configuration have the column names in the first row, we can skip this option. Moving on to the binning options, the time bin size argument specifies the frequency at which the eye tracking and ROI data are binned by in milliseconds. For this argument, I'll fill in 250 for the data to be binned at 250 millisecond intervals. The summary filter for and filter out options take in lists of ROI labels which are used to filter the ROIs present in the proportion of viewing summary. These filtering options can work in tandem or solo. If none are provided, then a filtered version of the proportion of viewing summary will not be generated. These arguments can operate on partial string matches or an exact match. In this configuration, I want to exclude any ROIs that have seen in their labels and the possible answers ROI. This means that the filtered proportion of viewing summary will include only the target and lure ROI. Okay, and now for the last section, entropy options. Since I'd like to run the entropy analysis, I'm changing the calculate entropy boolean to true. The target ROI entropy option functions like the summary filter for input and binning options. Here, I'd list the labels or IDs of the ROI that I'd like to include in the entropy analysis. I'm going to leave this option as none, which tells the program to include all ROI. And finally, the last option is the exclude diagonals boolean. This references the diagonals of the transition matrices that are created to calculate entropy. If this option is set to true, then the entropy will be calculated without transitions that occur within an ROI. Alright, and these configurations are all set to run. Please note that these input options will likely change in the future with app updates. I'll start publishing version updates on GitHub and note any changes that occur.